Welcome back to Sparky World. This is video number 5, part of phase 4, and the subject we're looking at today is resonant frequency. So it's just the basics for us. Resonant frequency. It sounds really weird, awkward, and difficult, doesn't it? And some lecturers can definitely make it seem this way, but for us in phase 4, it really is simple, so we're going to keep it simple. And we're not going to go into much detail about the science behind the frequencies or resonances. We're just going to focus mainly on what the question is in the exam. So if you want to learn more about the science of this and you're actually interested in it, there's loads of YouTube videos and articles on the internet that go into depth on the subject. And here's a class creator on YouTube called the Engineering Mindeset, and I'll put his link in the description. But for now, we just really keep this simple. So just like the title says, this is easy marks in your exam. The subject is important because it usually comes up at least once without fail. And the subject falls into the section with RLC series and RLC parallel. So that's the first 5 to 8 questions of your T1 exam. It's a great way to get another question with full marks. I'll explain how, first with a basic intro, and then we'll do some questions. So what's the meaning of resonant frequency? So when an RLC AC circuit is said to be at resonant frequency, it basically just means that it is the frequency which the values for XL and XC are the same ohmic values. So XL equals XC. That's the inductive reactance is the same value as capacitive reactance. So for example, XL is 10 ohms and XC is 10 ohms. So because they're the same, they cancel each other out, and the circuit is now fully resistive, like we assume that a house is, and its peak current is flown, so we'll have brilliant power factor. So you'll only be asked for resonant frequency in RLC series circuits in the exam, and this is for a reason, because the formula for the RLC parallel resonant frequency is the same, but the impedance is always full and the current is always maxed out at its lowest. So don't bother with this for the exam. For the exam, it's just RLC series resonant frequency questions. So that's all the science and theory that we need to know for this subject. That's it. And probably for this phase of the apprenticeship, that's all you need to know. There are only 2 things and 1 formula to know. So that's 2 things total and 1 formula. So this is exactly what they look like in your formula book that you'll have on the day of your exam. One of the 2 things you need to know is XL equals XC. So that's inductive reactance is equal to capacitive reactance. So when they're the same value. So when they're the same value, we have resonant frequency. And that's all that it means. And this is the formula here that we use to find it. And it's in the section called series resonance. So once you do enough of these questions, the formula will be stuck in your head, and it's only 1 formula, and that's all you'll need to know for full marks. So easy exam questions next. That's all we need to know for these questions theory wise. So like I said before, we'll focus mainly on what is important for us during the apprenticeship and what the exam questions are like, and they're pretty easy. So you do them out in 4 steps. Number 1, draw out the circuit as usual. Number 2, use the formula. 3, plug in the numbers that were given in the question. And 4, you get your answer, and that's it. So let's get at it. So here's an exam grade question worth a total of 4 marks. So 2 marks for the correct formula, which is half of the marks for the question overall. So that's 50% for just writing the formula. 1 mark for the correct answer, and 1 mark for the correct SI unit used for frequency, which is hertz or HZ. So again, like I said, this is easy marks in your exam. There's no reason to fail this one. Question 1. The circuit shown below is operating at resonant frequency. From the details given, calculate the resonant frequency of the question. So step 1 is draw out the circuit, usually, but in this case it's given to us in the question. So R equals 70 ohms, L 0.2, and C is 45 microfarads. Now, we just ignore R. It's there for no reason in these questions. It's just there to put you off. So step 2, write out your formula for half the marks of the question. Step 3, put in the numbers. And step 4, write out your answer. And even if you got the wrong answer and you put hertz, you got 3 out of 4 marks. But this example here is full mark question. So when you get an answer of 53.05 hertz, that's all there is to it. And that was kind of easy, wasn't it? So we'll worry about the theory when you're an engineer, but for now, train as an electrician. And in phase 4, this is all that you need to know. When it isn't made complicated and you get told all that you need to know to get full marks in the exam, stick with that. And it's a recipe for top marks. So let's do a few more. Example question 2. Determine the resonant frequency from the circuit provided and the figures that are given. So R equals 20 ohms, L equals 0.2 henries, C equals 20 microfarads. Like before, we just disregard or, and then step 1 we skip because we're given the circuit. So step 2, write the formula, probably for half the marks. Step 3, put in the figures that you're given. And step 4, find the answer. In this case, the resonant frequency is 79.58 hertz, and that's full marks again. Example question 3. With these figures in an RLC circuit, R equals 30 ohms, L equals 0.6 henries, and C equals 50 microfarads, show the resonant frequency. So step 1, just draw out your circuit, put in the figures. Step 2, draw out your formula. Step 3, put in the figures from the circuit. On step 4, find the resonant frequency, which is 29.06 hertz in this example, and that's full marks again. Example question 4 is for you to try. So question 4, using the RLC series circuit and components below, determine the resonant frequency. So pause the video now if you'd like to try. So I'll give the answer now. So just follow the steps. Step 1 we can skip because we got given the circuit. Step 2, draw out the formula for the circuit. Step 3, plug in the numbers, and then the answer, the resonant frequency. You should have got an answer of 79.58 hertz. Hopefully you got that. Now, thank God we're almost done. So in the past, they used to ask a strange version of this in the exam. They ask you to find the value of the inductor or the capacitor to get the resonant frequency, and they'll give you the frequency and one component value. So most likely you won't need this, and it probably won't come up, but it's better just to learn the two formulas and not need it than need it and not know it. And these formulas are not in your formula book, so you'll need to memorize these or learn how to transpose the normal resonant frequency formula. So these are the two formulas. Here's an example of the question that you're unlikely to get in the exam, but just show you how it works in case. So using one of the two formulas that we just showed in the last slide. So question 5, what is the value of the inductor in this RLC series circuit required for resonant frequency? Just like before, we get given R and C, but we're missing L and we're given frequency. So we just plug them in to the formula for inductor, and then we get an answer for 0.2 henries. So it's not hard, it's just different, that's all. That's the end. So other than the last example, which I wouldn't worry about too much at all because it's very unlikely to come up, we can see that the topic is really easy, and it's an easy hit for 1 or 2 questions out of 20. So the chances of getting at least one of this question is really high, along with at least one other power factor question, which we're going to look at in the next video. So practice just a few more of these and you're golden on resonant frequency. So just a few more topics, and that's T1 in the bag. So cheers and see you on the next one.